Hello, everyone. Welcome to all the new joiners and everyone who joined on Tuesday. Just quick introduction. I'm Beeke, and I'm a vice president at Goldman Sachs, working in the data engineering department. And my current focus is managing the program to open source Legend. And probably most of you are familiar with Legend by now, but just quick reminder of what Legend is. It's a data management platform that aims to provide solutions to data challenges across the entire data lifecycle. And we open sourced the platform in the fall of last year. And the code is available on GitHub for users to install it on their own premises. So today's session is a follow-up to the Legend 101 session we hosted on Tuesday. And there we created a human resource demo data model in the data modeling tool Legend Studio with the purpose of enabling systematic reporting of people-related data. So today, we are actually using a much simplified version of that model and map NH2 test database to it. That will hopefully give you a sense of how we could use a data model to provide data for use cases such as reporting of people data that I introduced on Tuesday. And as the mapping editor got a facelift recently, I'll also recap the model-to-model feature as well. So that means specifically we'll cover mapping a source data model to a target data model and test the execution. We will also map an H2 test database to a data model and also test the execution. And then we will query sample data directly from Studio. So let's get started with the demo. Hopefully everyone can see my screen. And before we dive into the mapping scenarios, I would like to introduce you to the data model we are dealing with. So as you can see, we have 4 classes here that represent 2 different data models. So the first data model, the human resource data model, has a firm and an employee class. Firm has a legal name attribute and a derived property employee count, and also has the employees attribute, which is of type employee. And our employee class has a full name and country, which is an enumeration. And our deprecated human resource model has an organization and a person class. The organization has a name property, and the person has last name, first name, and country as a string. And we also link these 2 classes as organization has an attribute called staff, which is of type person. So that's the data model we are dealing with today. And you may be wondering why I labeled those classes here as deprecated. Actually, I want to take you again on a little journey. And let's imagine that the hypothetical firm that I'm working in just recently went through a merger and acquisition and acquired another company that also had a human resource data model, but they represented their firm-related data in the organization class and their person data or their employee data in the person class. So now we would like to avoid that we have to remodel all of the acquired firms' data. So what we could actually do is just map their data model to the one of my hypothetical firm that we would like to use going forward. So that's exactly what we will do in the model-to-model mapping scenario that I will walk you through in a second. But before we do that, I would actually like to show you the constraints that we have both on the target and the source data model. And you may remember from Tuesday's session, constraints basically add quality rules to your data model. So our source data model, the deprecated human resource model, has a constraint on the organization class, which is that the name has to start with org underscore. And our firm class of our human resource model has a constraint that it needs to have at least 2 employees. And that will become relevant a little later on in my demo. Okay, maybe let me also just quickly show you the values of our enumeration, which is USA and UK as valid allowed values for the country attribute. Okay, so but without further ado, let me actually dive into the mapping. So for that, I will create a new mapping and I will call it model-to-model mapping. And the first thing I would like to map is my employee at the class to my person class. So the target should be employee and the source should be person, because person is the deprecated one and I would like to transform it into my employee class. So as you can see, I have the country and full name attributes here that require a mapping. So first, I would like to map my full name. So here, I think it would make sense that we map, that we transform first name and last name of our source data model into the full name of our target data model. So I can just do this and type in this. Great, so that completes our mapping here. And then for the country, I would actually also create a mapping for my country enumeration. So I will do this next. And as my source data model had country as of type string, I need to actually create some values here that so that we know what those need to be mapped to. So my source data model would have United States and United Kingdom as the incoming data, which would then be mapped to my USA and UK value. Okay, so now I can leverage that and also map my country. And now let's actually, now that the mapping is done, let's test the execution of this. So I right-click on employee, hit execute, and now Studio allows me to edit the query in a drag and drop style via a separate editor. And here I need to select graph fetch because we don't support projection yet. So I will do country, full name, save this. And now let's just see what's happening when I execute this. Okay, so it's actually throwing out an error here because country 23 is not any of the allowed values that I specified in my enumeration mapping. So let me actually put some data in here. So as you may recall, United States was one of the values that I specified. And maybe let's also make this a little bit prettier. And let's call our person Jane Doe. Okay, and here just to clarify, this is the data, input data that I'm specifying for my source data model. And now let's see what's happening. Perfect. So here we can now see that the mapping was successfully executed. And from our source values, where it's United States and Doe and Jane, it actually successfully transformed it into the shape that I specified in my mapping, which is the country USA and the full name Jane Doe. So now let's use just a slightly more complex mapping scenario. And this is, if I would like to map my firm class to my organization class. Because now we can actually make use of both the firm and the employee attributes in my mapping. So here I will map my legal name to the name, and I will also map my employees attribute to the staff attribute here. Now let's execute this again. Edit our query. Again, select graph fetch and select our values that we want. Oops. Okay, save. And let's just hit play again. Okay, now to our surprise, we would need to enter a valid value again. Okay, and let's also already fix this. And let's see what's happening now. So as you may remember, I walked you through the different constraints that are both on our source and our target model. So that were the at least 2 employees constraint and also the name starts with constraint. So Studio is actually letting us know that the input data is not, or is actually creating a defect, or the constraint has been not validated. So let me actually fix this one by one. So first, let's actually create a second employee in our input data. Maybe that is Mr. John Doe. And see what's happening. Great. So the defect on our target model has already been resolved. So now I would just need to fix our input data for our name attribute from the organization class. Let me do this again. And now you can see all defects have been successfully resolved. And we can also see that the mapping has been executed successfully. With having our USA Jane Doe, USA John Doe, and also the legal name org FINOS being successfully getting back to us. Okay, so now you may be wondering that what we can do now that we successfully executed these 2 mappings and tested them. So first thing we can do is actually promote this mapping execution to a test. So that would mean if any of our input data would change, the test would actually fail, and it would actually allow us to see what may be wrong in our input data. So let's demonstrate that real quick. Let's, for example, say I change the input data to be Jennifer Doe, run the test, and then it would actually fail, and I would also see where the data has been changed. So I can go back to the test setup, change it back again to Jane, execute, and it passes. So that's always a good rule to add tests to your mappings, just to make sure that you maintain high quality of your data models. And now what we can then do, once actually the functionality is fully open source, we could also promote this to the query to a service, which would then allow us to consume the query via a REST API or an executable jar. So looking back to our human resource data model scenario, where we were interested in creating these systematic people reports, an HR system could, for example, consume this service and would allow me to see the employee data from both my hypothetical firm as well as my acquired firm, because I successfully mapped those 2 data models. Okay, so that concludes the model-to-model mapping demo. And now I would like to go into the relational mapping scenario. So for that, we can actually ignore the deprecated human resource model, because that has now already successfully been mapped, and we can focus our attention on our human resource model only. So the first thing I would like to do is actually spin up an H2 test database that we can then map to our human resource model. And that we can do by by just creating a new relational database here. And we will call this H2 demo database. And as you can see here, unfortunately, we don't have yet an editor mode available to create your database. That will be coming soon, but for now, Studio is actually pointing us to the right mode in which we could spin up that test database, namely in the text mode. So let's click in here and then see that the core of the code has already been auto-generated for us. And I could now create my demo database using SQL code. So as it may be very boring for you to watch me typing away all this code, I actually done a little bit of prep work ahead of the demo, and I created the sample code for us. So let's look at this real quick before I use it. So I created a firm table, an employee table, and a country table with various columns, an ID and legal name for the firm table, ID, firm ID, full name and country ID for my employee table, and ID and country name for my country table. And I also created joins of my table so that I can query across the various tables that I'm creating. So that SQL code actually describes the schema of your test database. So, and that is what I will now use in my demo database. So let us paste this in here and see if it's compiling successfully. It is. Great. So now I can already tackle the relational mapping. So let me go out of the text mode and create the relational to model mapping. So, and the editor looks exactly like the one we just seen for, oops, and actually I did put that in the wrong one. So let me just do this really quickly again. Relational to model. Okay. Oh, I'm sorry, guys. For some reason, I am not putting this in the right one. There we go. Okay, so the editor, as I said, looks exactly like the one for the model-to-model mapping. And so I start by dragging in the class that I would like to have mapped to my database. So let's start again with my employee class, and the source this time is my database. So I can just, oops, I can just drag this here, select the right table, and then I can go and start my mapping. So first, I would like to map my full name attribute to my full name column in the table that I just created. And then I would also like to map the country attribute to my country name column. And because I created the join already in the database, I can select this here. So now let's see how this will look when we're executing it. So first, let's edit the query again. This time we can actually choose projection, pull this in, save it, and our query is created. And as you can see here, unfortunately, we don't support yet to auto-generate input data. Also, this is something we are working on. So we would actually need to write a little snippet of SQL code that would insert values into the H2 test database that we just created. So again, to not bore you seeing me typing away this thing, I also did already create this, and I will do, yeah, we'll show you this right here. So this is basically the code that lets you insert values into the table that you specified. So here you can see I have in my firm table, I have two legal name values, which is FINOS and Linux Foundation. And in my country table, I have two countries, USA and UK. And I also have my 6 employees with the names person A to person F. So this is what we will be now using in our mapping execution. So let's navigate back into here and then hit execute. And we can see that this now works fine. And we're actually retrieving the values of the country and the person. Great. So now let's also start mapping our firm class to the correct firm table. Yep, so that is the firm table, that is correct. And now I would like to map my legal name to the legal name column from my firm table. And as my employees attribute is of type class, I can actually map the entire employee table to this attribute. Hence, I'm selecting the entire join here. Okay, so that should now work fine. I'm executing this again, selecting the values that I want to have in my query, save it, insert the same test data that I just walked you through. And we can see here that now we successfully retrieving values from all the 3 tables that I set up for us in our H2 test database. I can see the country values, the person values, and the legal name value as well from all of my 6 people. Okay, so that also concludes the relational mapping scenario. Now you may be wondering again what we can do post successfully testing the mapping execution. So similar to the model-to-model mapping, we could now, once the functionality is fully open source, promote our query to a service and consume the data via a REST API or executable jar, which probably may not make much sense with an H2 test database. But as we're also supporting Snowflake in the code that has been released in GitHub, for everyone who is using their own installed version of Legend, you can also map it to Snowflake and use that for like real production data if you like. Another way what we can actually do now is creating ad hoc queries post creating that relational mapping directly from the Studio UI using the query builder. So that's what I would like to show you next. So for that, we would need to define both a runtime and a connection. So let me create the connection first. And you can do this again here. You need to be careful that you're choosing relational. And then I will call this H2 demo connection. And here, the database type H2 is already correctly selected for us. I will just basically spin this up locally with some test data that I create by myself. And it's again the same ones that I just walked you through. So that's already everything we have to do here. Now we're selecting or we're creating a runtime. And here be careful that you're choosing our relational mapping. So I will do this. Select our database here, drop in the connection, and all of everything that we need is already auto-populated. So now we should be able to actually start querying our data. So to do this, let me just right click here on the firm class, choose our relational mapping that we just specified. And then we can drag and drop the values that we are interested in, or in this case, the attributes we are interested in. And we can hit play. And it's actually retrieving the data for us that I specified in the H2 test database. So maybe let's rearrange a little bit the columns. We can do this just by dragging and dropping them here. And let's play it again. And now it looks a little bit nicer. We can actually see that we have the two different firms here with 6 employees and living in different countries. So now maybe I'm only interested in looking at the employees that work in the FINOS organization. So I can actually apply a filter real quick and say that my legal name should be FINOS. And then let me play this again, and the filter is correctly applied. So, and now for everyone that joined the demo on Tuesday, basically to close the loop, I also again created a derived property called employee count in my firm class. And now you may have been, or you may remember that one of my questions was that as the hypothetical firm's head of data analytics or people analytics, that I wanted to get the count of my employees. So I can do that really quickly from the query builder here as well. So let me actually select the legal name so that I know this by my by firm, and then drag and drop this derived property in here, which is the employee count, and then hit play. And then I could directly see that I have 3 employees per firm respectively. Okay, so that concludes what I wanted to show you. Maybe a quick recap of what we now learned in these 2 sessions. So we learned how to create a sample data model in Legend Studio focused on answering business-related questions to enable systematic reporting of people data, right? And this was just one specific use case that I walked you through. And then today, we actually learned what we can do with our data model. We can create a model-to-model mapping and a relational-to-model mapping, and expose the queries via services once the feature is fully open sourced. Or what is already supported is we can do ad hoc queries leveraging the relational mapping directly in Studio. And one last thing that we can do with our model, remember what we went through on Tuesday, is also that we can create a file in a different coding language via our code generation feature in Studio that would allow us to integrate the data model into other systems. So hopefully today's and Tuesday's demo gives you a good overview of the core functionality of Studio.